Welcome to qnawire.
So for part A of our question, we're asked to determine the bird's speed relative to the ground. Okay, so the bird's speed then relative to the ground is going to be the tangential velocity. Well, the tangential velocity, v of x, is going to be equal to the circumference here, which is 2 pi times r, the radius, which we were given, divided by the time that elapses, t. So plugging those values into this expression, we find that the tangential velocity in the x direction is 7.54 meters per second. Okay, so now that we found the velocity in the x direction, we can use that velocity and the velocity in the y direction, which we were initially given, to find the speed relative to the ground. Because the speed relative to the ground, here, and let's indicate this as part A, is going to be equal to v, which is equal to the square root of the velocity in the x direction squared, plus the velocity in the y direction squared. We were given the velocity in the y direction. We just found the velocity in the x direction. Plugging these values into this expression, we find that this is equal to 8.11 meters per second. And we can box that in as our solution for part A. Part B then says to find the bird's acceleration, both magnitude and direction here. Okay, so for part B, well, there's no acceleration in the y direction, therefore all the acceleration is in the radial direction. So this is alpha, and this is going to be equal to v of x squared divided by the radius r. Well, we just found v of x. Plugging that value into this expression, we find that this is equal to 9.47 meters per second squared. And this is in the radial direction, or the theta hat direction. That's meters per second squared there. We can box that in as our solution to B. Part C, it wants us to find the angle between the bird's velocity vector and the horizontal. Theta is going to be equal to the tangent minus 1 of the inverse tangent of v of y divided by v of x. Plugging those values in this expression, we find that this is equal to 21.7 degrees. We can box that in as our solution